So today's lesson is on quadratic word problems and radical equations. These two things really don't have much to do with each other. The quadratic word problems are just word problems using the methods that we've used, factoring, square root method, completing the square, or quadratic formula. And then radical equations are equations with radicals in them. So we're just having two topics today that we need to get through both of them. So we're first going to start with quadratic word problems. So the steps to solve all word problems are: step 1, define your variables. Figure out what you don't know and give it a letter. There may sometimes be two variables, in this case probably only one today, but this is for any word problems really. Step 2, draw a picture or sometimes a diagram or chart, if at all possible. Sometimes that's not possible and you don't have to do that step. Step 3, write an equation. This is the thinking step. I call number 3 the thinking step. That's where you have to figure out how to translate all those words into algebra. Step 4, solve the equation. And step 5, check your answer with the word problem, with the words, okay? Don't go back and check with the equation that you wrote in step 3. Go back and check with the words. And then make sure you answer with units, meaning feet, meters, seconds, years, whatever it is that you're trying to solve for, make sure you put a unit on it. So these steps can help you solve any word problem in math. Before we actually start tackling them, I have a couple things that I'd like to talk to you about. One of them is consecutive integers. So we need to know what they are because lots of word problems use consecutive integers, and you need to know what that is. So consecutive integers, well, they are integers, and just to remind you what integers are, they are positive and negative whole numbers that are in a row or back to back. Kind of like 6 and 7 are consecutive integers, or 12 and 13 are consecutive integers. So let's list a couple more here. If I have a first number and a second number here, if my first number is, I don't know, let's say 2, what is the next consecutive integer? Well, a lot of students will be able to say, oh, that's 3. All right, what if I give you 8? What is the next consecutive integer? 9 and one more. How about 15? 16. How are you getting from one to the other mathematically? I know you're just saying, well, it's just counting up, but what property, add, subtract, multiply, or divide, are you doing here? Well, it turns out that we are just adding 1 every single time. So 2 plus 1 is 3, 8 plus 1 is 9, 15 plus 1 is 16. So what if I gave you the first number is an unknown variable, x? How is it that if the first number is x, how are we going to get to the next number? Well, if we follow the pattern above, all we were doing is just adding 1. So if the first number is x, the one right after it must then be x plus 1. So whenever you see the words consecutive integers in a word problem, I want you to let your first number be equal to x, and then the second number will then be x plus 1. Okay, let's try this again, but this time let's do consecutive even integers. So every number I'm going to give you is going to start out to be an even, and you have to find the next consecutive even number. So let's start with an easy one, 2. So 2 is an even number. What is the next consecutive even number? Well, that's 4. Because 2 and 4 are back to back, but both even. What if I gave you 6? Well, the next consecutive would be 8. And what if I give you 14? Well, the next consecutive would be 16. What is the operation we're doing from the first number to get to the second number? Well, if you start at 2 to get to 4, you're just adding 2. If you start at 6 to get to 8, you add 2. If you start at 14 to get to 16, you add 2. So let's assume that the first number is x. How are you going to get to the next number? Well, if we follow the pattern, that's just really add 2. So if my first number is x, my second number will be x plus 2. If you ever see the words consecutive even, the first number is going to be x and the second number is going to be x plus 2. To get to the next even one, you just add 2 because you're skipping over that odd one in between it. Okay, so let's try consecutive odd now. So if I give you a first number as an odd number, so I have to make sure that I start with an odd number, so 3. What's the next consecutive odd number after 3? Well, that's 5. How about 9? Next consecutive after 9 is 11, and one more, we'll do 15. What's the next consecutive after 15? 7. Just like we've done in the last couple, how do you get from 3 to 5, from 9 to 11, and from 15 to 17? This is an interesting case. We're still adding 2. This confuses a lot of people because they're like, wait, didn't we just do that for even? And this is odd? Wait, yep, that's still basically the same. So if I give you the first variable is x, and you're trying to get to the next odd integer, notice I have to start with an odd x for this to work. So if I say x is odd, the next consecutive odd would just be x plus 2 more. So if you ever see consecutive odd integers in a word problem, you're going to let the first number be x and the second one be x plus 2. So then I usually have students say, wait a minute, why are the consecutive even and the consecutive odd the same? They're not the same. Evens and odds are not the same number. Well, the answer there is if your first number is even because someone told you it was even, or the word problem says it has to be even, to get to the next even, you're still adding 2. Whereas when you're doing consecutive odd, well then the first number has to be odd. It starts off to be odd. Now, if you're solving, you don't have to worry about odds or evens. You just need to start with x and x plus 2. But then the answer will either come out even if it's a set of even consecutive integers, or it'll come out odd if it's a set of consecutive odd integers. So yes, they're the same. It's just that the answers will come out different if it's an even versus it's an odd. The last thing I want to talk about before we get to the actual word problems is to go through a couple common English to algebra translations. If you ever see in a word problem a number, well, that just means your variable, and we usually use x, okay? That means the thing that's unknown. If you ever see the word product, that means multiply. For example, if the word problem said the product of 4 and a number, well, that would be 4x. Multiply, because that says multiply, so there's a multiply sign in between the 4 and a number. Well, we already said number was x, right? So product of 4 and a number is 4 times x. Quotient means divide, or really the answer to a divide problem. So if it says the quotient of a and b, well then that's a over b. Sum means to add, or really the answer to an addition problem. So if it says the sum of a number and 12, well, we said anytime you see a number, that's going to be x. So the sum means plus. The sum of a number 12 is x plus 12. Difference means subtract, or really the answer to a subtract problem. So if it says the difference of a number, okay, a number, every time we see a number, that's x, and 5, and we're subtracting because it says difference, it just goes left to right. Because a number came first, then that makes sure you put that number first, and then the 5 comes second, and that's why the 5 comes second. So make sure you're reading it correctly left to right. Is. If you ever see the word is in a word problem, that means equals. So if it says a number is, well then your equation would be x equals, and then whatever else is there. I didn't really finish that one. Of. Of means to multiply most of the time. So in this case, 1/5 of a number. 1/5 of means multiply a number x. So a fifth of a number is 1/5 times x. Square means raise to the power of 2, or often we call that square. So if it says the square of a number, that's going to be x squared. Here's another example. If it says the square of the sum of a number and 3, okay, what are we squaring here? We are squaring the sum. So if you're trying to square a sum, we have the sum squared, right? But then you have to keep reading, and what does the sum actually mean? So I'm going to come in and erase the word sum. And what can we put in for sum? Well, it's the summing a number and 3, so that's x plus 3. Notice that this has parentheses. If you ever see product, quotient, sum, or difference, and you're doing something to that, for example, you're squaring the sum, you need to put parentheses around those product, quotient, sum, and difference, because all 4 of those, even though they do mean multiply, divide, add, and subtract, it really means the answer to a multiply problem, or the answer to a divide or the add or subtract problem. So if I'm squaring the sum, I'm really squaring the answer of these two things being added, which means I need to have parentheses, which is a bit tricky. Twice means to multiply by 2. So if it says twice a number, that's just 2x. But what if it says twice the sum? Twice the sum. Well, I'm twicing the sum, and when the sum is the answer to some other addition problem. So I'm going to come in here and erase sum and replace sum with whatever that thing we're adding. What is it that we're adding? Well, the sum of a number and 3. So that's x plus 3, and we're twicing that. That's very similar to what we did with the square of the sum. Because you see that word sum and we're doing something to the sum, we're squaring it or we're twicing it, you have to put that sum in parentheses. More than means added to. Okay, this is a little bit funny. Whenever you see that word than, it's going to be a little bit weird. It says for more than a number. See that word than? Whenever you see than, what happens is the order of the English actually switches for algebra. So if it says for more than a number, you really take x plus 4. Let me give you an example. So let's say I'm talking to someone in this class. Let's say, I don't know, they're 20 years old. We'll make it nice and round. So they're 20 years old. If I tell them that I am 4 more than their age, if I am 4 more than their age, then what do you do in your head? Well, you would take 20 and you would add 4 to it and you'd get 24. Now technically 4 plus 20 is the same thing as 20 plus 4, but if I say I'm 4 more than somebody, you automatically think, oh, how old are they? Okay, 20. Oh, okay, then add 4 to it. So it actually switches the order. Now, in addition, it doesn't matter all that much, but if you do it in subtraction, for the next example, less than, I see that than, okay, less than means subtracted from. Okay, so if I say 4 less than a number, okay, let's go back to our example. If I have a 20-year-old in class and I say I'm 4 years less than you, well, you don't take 4 because it came first in the sentence, less 20, and I'm negative 16 years old. That doesn't make sense at all. If I say I'm 4 less than a 20-year-old, then you take 20 less 4. But do you hear the words that came out of my mouth first? I said I am 4 less than the 20-year-old. Do you hear how the 4 came out of my mouth first before the 20 came out? So even though 4 came out of my mouth first before 20, we actually take 20 minus 4, right? Anytime you hear that word than, it switches the order of what was said when you're writing it in algebra. 4 less than a number is really x less 4. And try not to blame the algebra here. I think it's an English problem because who says 4 less than a number? If I was creating the English language, I would probably say the number less 4, because that makes more sense. You take the number and then you subtract 4 from it. But, I don't get to make the English language. And then the last one, from. From also means subtract. And that's another case where you take the numbers and you reorder them because of that word from. So thans and froms reorder things. So if I say take 4 from a number, that's my number, and I'm taking 4 from it. So from switches the order and than switches the order. So hopefully that English to algebra translation will help you when we do our word problems in a minute.